There we go. We're
All
good.
right. Thank you. Welcome to the Sail Code Crafters meetup for April. And this month we have Matt Wynne joining us. He's going to talk about shaving yaks with AI. He's a fabulous developer and one of one of the top three things to come out of the Queen City in BC, Nelson. And we can talk about what the other two are later. Anyhow, take it away, Matt. Yeah, excited about this.
Hey folks. Yeah, so this is like an experience report really. Um I actually probably like a year ago even I was really like kind of had my head in the sand about AI. I just wanted it to all go away. I hated the idea of it. These like rich people in Silicon Valley are just gonna take everybody's jobs away and hoover up all the money, and it's horrible. Um, and it's, making artists penniless, and I just want it to stop and go away, and I don't want to think about it. Um, and at some point in the last year, I was like, this isn't going away, is it? I guess I'd better figure it out. And I feel like I've had a kind of like epiphany about how amazing this technology is. And I still think the capitalism stuff is extremely worrying. Um,
Mhm.
but that's a separate conversation, right? I think as technologists, we have to understand this and figure out how we can make best use of it because it is, I think it's changing everything. Um, Sorry if that sounds really hypey, but that's like the journey I've been on. And so this is like about, and I think if you, depending on where you are on the spectrum, from that sort of cynic that I was a year or skeptic that I was a year ago through to sort of feeling really excited about it. Um, I've already forgotten what I was going to say about that, but like, yeah, this is hopefully going to be. Oh, right, yeah. Well, depending on where you are on that spectrum, I think it's really helpful to have a side project, to have a hobby project where you can play with this stuff without, it feeling like well, you're doing real work, so you can't take any risks. And where you get the tokens for that from is again a difficult question because they're not cheap. But I really encourage you to try and find a way to have a side project. So Yaks has been my side project, um, and it's made of Rust. I've never written Rust by hand. I barely read the code, and yeah, I really like this code base. Like I like working with it. Like, how the hell does that work? So yeah, I was gonna try and like do this demo. And the bit of context for the demo is I was at the Agile Open Northwest conference, which a few of you were at, and there was this evening session that Lada Kessler ran, where she gave us this like refactoring challenge. It was super fun because they had like agents trying to solve the refactoring challenge and humans, and they were kind of like in a race. Um, anyway, we could talk more about that, but I was going to try and leave a robot doing a refactoring challenge. So can I? This thing's gone full screen and it's like completely taking over. Let me out of full screen, please.
Just as an FYI, Matt, I was the human in that, or not the human. I was running one of the bots.
I know, yeah. Yeah. So I've got a bot as well that I'm going to try and run. So let's see. I think I've got a script in here, bin. I haven't really practiced this bit. So that's going to run a Ralph loop. Oh yeah, because I need my Anthropic API key, right? This is what I was saying about the tokens. I'm going to do that off screen. Hold on a second. Because it's literally in the terminal. Okay. So this is going to run what they call a Ralph loop, um, which is just basically like running a Claude prompt over and over again. And we can dig into that a bit more if you're interested in what that's about. But what this is going to do is like it's going to let me actually show you the prompt a little bit for a minute. Um, So it's telling it to do some refactoring on this like super messy code base. And the loop is like, see if there's anything to do on the Yak map. If there isn't anything to do, have a look and find something to do, add it to the list. If you do something, mark it done and make a commit, and then go back to the beginning. And so like every Ralph loop, it's going to do a pass down this prompt. So it's going to make like one tiny iteration to the thing, make a commit, and then come back. So I think I can just leave this running with like bin show yak map. And there's nothing to see right now because it's thinking, it's having a look at the code and deciding what it's going to do. But this might give us a picture of like what a yak map looks like in a few minutes because it's going to start to grow one. And also just a way to think about like how these things can be used because I originally created this tool because I really like using discovery trees as a human. But I had this kind of hunch that they can also be useful for robots as well, because I keep seeing this pattern that like what's good for the humans is good for the robots. And so maybe, yeah, let's see. We'll just leave this kind of organic thing to happen in the background while I'm talking, because it is slow, Ralph looping. So yeah, the thing I'm beginning to understand about working with agents is that there's this like spectrum from kind of working with Claude, say, like in a CLI and prompting it, which is almost like a REPL. Like when you're debugging some code, it can be really useful to use a REPL because you get very fast feedback, but it's also sort of like very human intensive, right? Like you're having to guide the work all the time. So it's really good for discovery when you don't really know what's going on, but it's also very human intensive. And then there's a spectrum right over to this like idea of a dark factory where you write you create a really big specification, you get a really good harness of what good is going to look like, and then you just let the agents run for like hours, and they'll produce something out at the end of that. And there's a spectrum between those 2 points. Um, I've been getting a lot of enjoyment out of using kind of sprints. So the sort of thing that would take like a couple of pairs of humans a week. You can write a much smaller spec for and create a smaller kind of harness for the agents, and they can produce that for you in like a matter of 40 minutes, an hour and a half, something like that. And I think so there's this kind of spectrum. Um, and why am I telling you that? Because I think the the work with Yaks is like a way to visualize what this work could be like and to start to build towards being able to work on things as a harness. Like you need to have a place to write down what it is you want and what is going on. And as I built Yaks, I started to be able to work in like bigger and bigger chunks as I developed more of a kind of harness that gave me confidence that the agents could make changes to this thing and they were going to make good changes that I was happy about. So that's kind of what I'm going to talk about from a like crafting perspective. It's like, what did that harness look like so that I could be confident when I like wanted a change, that it was going to come out good. And I don't just mean good in terms of it did what I asked for, but also that the design of the code inside was staying healthy so that I knew it was gonna like continue to be able to grow, right? It wasn't gonna hit some wall of technical debt. So let's talk about that harness, like what I did to try and keep the code from rotting. Um, I think I probably started with ADRs. Does everybody here know what I mean when I say ADR? Does anybody not know? I'd love a question.
It'd be
What can
good
I
to
do to
hear
make
your
you tell me, Ahmed? Sorry.
it would be good to hear your perspective on it. I mean, I've yes, I would like some grounding on it.
Yeah, sure. So ADR stands for Architectural Decision Record. And I have found them really useful, again, in teams of humans to keep a kind of ledger of how our decision making has evolved over time. So I would tend to commit these into Git with the code. I would tend to date them, and I tend to have a ledger that sort of says like, oh, actually, this one from last April is superseded by this new one that we made in December, right? We changed our minds about this, and you can kind of document your evolving decision making about the code. I think I've got one. There's an example of one here, right? So but it's basically like a pattern. You're going to write what was the context that you made the decision in, what was the decision that you made, and then what are the consequences of making that decision. So there might be something you've made some trade-offs, right? Some things are going to get easier, some things might get harder, but there's on balance you've made that decision. And I found that having ADRs is a really, really good way of keeping the agents in check from a design point of view, right? Like I want an architecture like this, and I can periodically ask an agent to go in and check, is the code actually like the ADRs say it should be? Or is there some pattern in the code that we haven't expressed in the ADRs, right? It could be a two-way street. But trying to keep those things coherent has been a really valuable thing. And it's not like you need to do that every iteration, every commit. But I would find like after a sort of chunk of behavior that I'd added, I'd be doing an architectural review to just take a step back. And it's amazing actually. Like if you get an agent or even a couple of different agents to do an architectural review, you'll get a pile of like a dozen things that it's found. And you're like, oh yeah, that's a good idea, and you can go in and fix them. So ADRs is one part of my harness. The other part of the harness from a sort of behavior point of view, like what do I want the thing to actually do? My background is with Cucumber, and I found there's a Cucumber for Rust. So I added it to the project. And generally, like when I was adding new features, what I'd be doing was kind of working with the agent, getting it to interview me to basically generate the specification as Gherkin or as changes to the existing Gherkin. And we could really go back and forth in a lot of detail sometimes about some of the scenarios. And that becomes another part of the harness, right? We've got acceptance tests that say this is what it should do. The ADRs are saying, and this is like how it should be implemented. And then obviously, like the robots are, they write tests. They don't mind writing tests. They don't really do TDD, do they? But they write tests. But I found that I was worried about the coverage I would get from the unit test. Like I didn't really trust the agent to be writing a unit test all the time. Like sometimes it just wouldn't. And I also don't like I've had instances at work where they've just written these like complete theater tests. They don't do anything. Like they do a setup and then they take some random action and then they do an assertion that they set the thing up in the first place. Like it's just nothing. It doesn't do anything. And we've all probably seen in organizations of humans when some high up person says, "Oh, we need 100% test coverage from every team," and then people are just writing these like terrible tests that don't assert anything. And so that doesn't seem like a good thing, a good constraint to put on the robot is say code coverage because they're so easily going to game it. So what can I do instead? Well, I'd heard about this thing called mutation testing. It sounded great, but I'd kind of never had the patience to put it into a project. But this time I was like, well, I can just point a robot at that and just say like, I want mutation tests, make it so, right? And so I got to start playing with mutation tests. So I used the BDD scenarios as this like boundary object for agreeing with the agents about what do I want from the behavior. And this is one where like we're talking about quite a complicated scenario. So one of the cool things about Yaks is like if you and I have both got a clone of the same Git repository, we can type Yaks sync and it will push the Yak map up to our origin and pull it down and it'll synchronize our map so we can both see the same discovery tree on our local command line. But that gets complicated, right? Like what if you deleted the one that I added a child to, right? There is kind of complicated scenarios. So I was able to work through those kinds of complexities with the robot in this medium that I found really helpful as a way of like describing to it what I wanted and working through the intricacies of that. yeah, it worked really well for me, and it seemed to work well as a boundary object for the machine to kind of keep it on rails then of like well, it has to do all of these things. I have a hunch, I haven't really checked this, that it also helps it to like understand domain language because we're using words in these scenarios that then need to be down in the code as well. And I think it's probably like biasing the model to use to think in terms of those words. But I haven't really checked that. We talked about ADRs. Yeah, and I would periodically give it a prompt like this to get it to check for the kind of coherence between the ADRs and the code itself. Um, I also put in some like linters and complexity thresholds. I actually realized when I added this slide last night that like this is a terrible cyclomatic complexity score. I'm really letting it off the hook here. I put it in and I just haven't bothered yet like cranking it up. But again, this is like a thing that would be pretty easy to do at some point if it's bothering me, right? Is I can just put the agent in a loop and just say like, right, I want to get that score down to 20. Just keep going until it's done. Right now, I want to get it down to 10. I just haven't put the investment in. But yeah, the mutation testing's been really interesting. I would love some hands or whatever from people who have used mutation testing in practice because I was a real novice with it until this project. Has anybody else used it in practice? Yeah, so one person, two people.
I've used it, but not necessarily with AI at the reins.
Yeah. So just to be clear about what mutation testing is then, because there's a bunch of us here and only a few people have used it. What we do with mutation testing is we take a test suite and we run it, and then we take the code and we change the logic in the code, right? So if there's an if statement that's like A and B, then do this, and we change the logic in the conditionals. So now it says like if A or B. So we've mutated the code, and you would expect if you mutate the code, if you've got good test coverage, that a test is going to fail, right? And so when you do that and you don't get a failure, that's called a mutant. You've like found a mutant. You found an instance where there's a bug in there's the potential for a bug to leak in the code, right? Somebody could make a mistake and no test is going to catch it. So this is, I think, is a good way of forcing the agents to get you good test coverage is by hunting for mutants. And it's slow, like it can take a long time to run a full mutation test because it's like however long your test suite is multiplied by however many conditionals there are in your code base to mutate, right? So it can take a long time to run. But I learned that like you can run it on a diff quite effectively. So you can just look at like what are the changes in this diff where there could be logic, where there are conditionals. That made it a bit quicker. Um, and then I periodically run a thing that does like mutants on the whole code base, like as a sort of once a day thing in CI. Um,
Hey,
and
Matt,
yeah,
Steve has his hand up.
oh yeah,
Hey, so you're using a library to do the mutation testing, right?
yeah, some Rust library, yeah,
Okay, yeah, so that's what I've typically done too, but I've also seen people like creating skills around this to actually get the agent to mutate the production code. Paul Hammond's been posting about that, and that's something I've been wanting to explore.
right. So it's like a more kind of deliberate looking at the getting the agent to use a bit of intelligence around well, like where would the weaknesses be rather than just a sort of blanket, let's try mutating everything.
Yeah, but that also like opens it up for, I mean, non-deterministic kind of like, can you trust that?
Yeah,
Um, but yeah, I mean, most of these like libraries, you can like target them as like a subset, like you were talking about. Yeah.
yeah. So one of the things I found interesting about this when I started using it as a practice is that there seems to be like two types of feedback. When the mutation tests fail, there's like two things you can do with that information. The obvious thing to do is just like patch it with a new test. Like, oh, we've got some behavior in the code that we didn't have a test for, so we should write a test to capture it. But like, what if that is behavior that you don't really want? Or what if that is behavior that you don't actually care about and shouldn't really happen? And it occurred to me that like oftentimes when you see a mutation leaking, it's not because the tests are weak, it's because the model is weak. Like the design that you should, like ideally, you should be able to just model yourself out of this situation so it just never, it can't happen because the code just doesn't have a conditional for that. Um, so that was a place where I felt like I still needed to come into the loop. And so I have a skill about triaging mutants. So when we've run the mutation tests, it kind of goes through them and it analyzes them and it says like, is this just a test that needs patching, or is this maybe revealing a design mistake? And if it looks like a design mistake, then it'll come to me and we can like have a conversation about modeling. So this has been really fun, right? Because it means that even though I can't really read Rust, and I don't really know how the code's been implemented because I haven't had my hands on it, I still have this kind of sense of what I want the model to look like, right? Because I use the thing, I think about how I have a model in my head. So this has been a place where I can kind of intervene at a level that's interesting to me, right? I can talk with the model, with the LLM about how I want the model and the code to be expressed, and help resolve these. This has been a good place to like sense for where the LLM has generated a bad model or a model that doesn't align with the way I think about it. So I thought this was really interesting. And I think I wouldn't have invested in mutation testing for a side project like this if I'd written it by hand. But there's this great sort of virtuous cycle here where um, having these practices available helps to harness the AI to make sure that the code it writes isn't shit. And having the AI available enables me to implement these harnesses that I might not have afforded to do otherwise. So I think I've actually like done more refactoring on this project than I might have done if it was a. It's certainly, yeah. It's just kind of generally grown further, and I've been able to keep the refactoring going because it's so much easier to do. So I'm going to talk a bit about like, or have we got any questions about that, about the harness before I move on, actually? Has anyone else got anything they
I
want to
have
bring
a
up?
I have a question.
Yeah.
Um, so I have I just recently retired and after 50 years of coding and um, haven't stopped coding. But the fundamental thing that I tell teams is if you're relying on integration testing only, you cannot rely on the validity of the code because the combinatorics are crazy,
Yeah.
right? Of the pass through the code and all this jazz. And so this mutational testing seems like it's fundamentally based upon an alternative model of integration testing. And it's unclear. I'm not saying it's useless. I'm just saying without good unit tests, you just don't know what you're doing. You don't know what's really being discovered because if you don't have unit tests anyways,
Yeah.
if you're not focused on unit tests, then you can't necessarily know what the problem was. It seems like if it didn't find any, because the mutational tests seem like they're going to be even slower than integration tests if you're trying to get good coverage.
So I'm not quite sure what you're saying though, because the mutation tests are using the unit tests, so they're running fast tests. And a thing I haven't mentioned yet is that one of the ADRs that we came to relatively quickly with this project was to use a hexagonal architecture. And so with that ports and adapters architecture, I'm able to make sure that those feature tests, the acceptance tests, they can run, they do two passes. So I've got two like adapters for the actual like cucumber steps, that one of which just runs against the core domain. So there's no IO at all, right? Um it doesn't write to Git, it doesn't write to standard out. It's just like wrapping the logic that's in the core domain. And then there's another version that actually like uses the UI as like a human would, and integrates with Git, and those tests are much slower. The mutation tests only work on the unit tests. So I've got this kind of like layers of testing. There's the slowish acceptance tests that go through the full stack. There's the faster acceptance tests that just hit the core domain. And then there's unit tests on, yeah, there's domain models, but also all of the adapters, like the bits that talk to Git and so on. Um, and yeah, the feedback from mutation tests can be relatively slow. But my sense is that, like, if I want a robot to merge a branch, if I force it to get through the mutation test gate before it can merge the branch, I'm then confident that like it hasn't written crap unit tests. It hasn't cheated on those unit tests. So it's sort of worth it for me that they're a bit slower. Does that make sense?
Yes, yes. If the primary goal is that you're trying to validate that the unit tests aren't crap, then I can see how it brings value to the table.
Yeah.
Yeah.
And really, this is like the whole process here of developing this harness. Like, this is where I've ended up now, but it's been evolving the whole time where I've just like looked for gaps where it's like, where could the robot cheat? Where could the robot and its non-determinism do stuff that was below my standards? And then how do I add guardrails and harness around it so that it just can't? So it gets the feedback. And this has been, one of those ways. But I'm super interested from all of you if you see any more gaps and like other things that I could add. Has anyone else got more questions about the harness before I move on?
Yeah, I do, Matt. Um, not necessarily a question, but you're going through this, and I'm on a similar journey, and have not layered in mutation testing yet. However, what I've started to do is have two different layers of tests, and this gets a little bit to what George was asking about too, is I've got more of my behavior tests up at the top, which are the equivalent of your architectural. And then I'm still adding in unit tests as well. And I'm running a part of my loop has it running some code analysis, determining code coverage and trying to get that number higher. Now, where I've seen it and why I've broken it up like this is I actually have a hook in place that says that AI cannot modify any of my behavior tests for any reason. It has to consult a human before it adjusts those. But unit tests, it tries not to, but it can adjust because that's the implementation detail.
Yeah.
Mm-hmm.
Yeah, that's a good one. I actually so the dark factory thing that I alluded to there, the strong DM people, I got the privilege to hang out with Justin McCarthy from Strong DM last week, and when they did some of their dark factory projects, they would keep those acceptance tests in a separate repo. So the agent that's working on the implementation can't even see them. It's
Uh-huh.
just like it, or like you put them in a binary, so it just like runs the tests and then it gets the feedback, but it has no affordance to be able to change them. I think
Right.
that's a really powerful pattern. Yeah.
Yeah. Yeah. No, and I still every once in a while I will adjust the behavior tests, but the hook is deterministic, so it cannot change
Yeah.
behavior tests.
Yeah.
Uh,
And this is another thing that I've realized about the harness is like the more stuff you can move out of skills into deterministic scripts and just be like, no, you don't, this is how you merge a work tree back into main. You run this dev merge command, and that's going to run all my tests. It's going to make sure that everything's passed. It's going to make sure that the head of this branch is up to date with main. It's going to make sure you haven't got more than n commits, whatever. I can do all of my like quality assurance on that change before I let it merge it in, rather than like writing a skill which it may or may not pay attention to. It's
yes.
much easier just to go, here's this tool, use this tool. Yeah, it works a lot better. So
Yeah.
sort of like seeing those patterns in your work and then boiling them down into tools and giving them the tools to run seems to be a really good way to work with them. Yeah.
Love it.
All right. So I'm going to talk a bit about like why I built this tool. Um, I tried beads. Has anybody here tried beads? Steve Yegi's thing? Yeah. And when I saw beads, I was like super excited because I've been using discovery trees for a long time. I really think about work that we do as this like nested graph of problems. And it was so exciting to see somebody building a thing that supported that. And so I started using it on a project, and then I just kind of like hit a bit of a wall with it. Like it was frustrating. Um, One day I found myself on a feature branch working on this thing, and I found a bug that was unrelated to the feature I was working on, and I wanted to put the bug into the issue tracker so that we didn't forget about it. So I added the bead, and then I had to like commit the JSON to Git, and then I realized it was in the feature branch, and so I couldn't share it with a colleague who could have picked it up and worked on it. So then I went to main, and I like pulled cherry picked the commit into main, and I tried to push to main, and I remembered that main was protected, so I had to make a pull request. So I had to make a pull request to just add this like bug into the issue tracker, and that just seemed terrible to me. Um, and the more I used Yaks, the more I kind of felt like the the governance of the project was questionable, let's just say. Like he's just he's been having a fun time vibe coding it, and that's great. I'm happy for him. But it's a bit of a mess. It's got a lot of features that I don't need. It's got a lot of code that I don't think anybody really understands. So not invented here. I fancied like I'm going to have a go at trying to do this myself, and maybe I can do it better. Um, so one of the things that I think is better about Yaks is that it uses this like hidden Git ref to synchronize. So you don't have to merge your feature branch to merge your changes. When you type Yaks sync, it's going to push. It's actually because it's using event sourcing. We can talk about that. It's going to push the events about the changes that you've made to your Yak map to this hidden refs notes Yaks. And then any of your colleagues can pull that down, and they'll get those changes reflected in their graph. So you can sort of secretly pass these Yaks to one another from whatever clone of Git you're on, whatever branch you happen to be standing in. You always see the same Yak map. Super cool. Um, Yeah, yeah, yeah. I mean, this is just discovery trees. Who here is using discovery trees at work regularly? Plus pages.
They're my baby.
Yeah. Well, I've got a slide about that, Steve. I I've been using this technique. I think a lot of us have discovered this technique by ourselves, right? Because it's just sort of natural. Um, and I really take a lot of inspiration from Woody in various ways. But I really like this quote about like we don't really know what the work is until we start doing it. And I think it's like in many contexts, this is true of the robots as well. Um, this is the video I always like to show people. This is this show called Malcolm in the Middle. I actually didn't really watch it because I grew up in the UK, but have you seen this? Like what did he start out doing? I can't remember, but he finds himself fixing his car, fixing his car.
The light bulb was
A
out.
light bulb, right? He's going to change the light bulb. Yeah. And this is like all our days at writing software, right? It's just like a continuous discovery of new problems hiding within other problems. Um, and I think these tools that we have been using just like don't really fit with this era as we're starting to move faster and faster either. I'd question that. Um, and I just wanted to like acknowledge the folks that I've learned more about discovery trees from. Um, so yeah, this is a CLI. Yaks is a CLI for interacting with a discovery tree. I got like really into it in February, March, and kind of got this lump of idea out of my head, and I'm now mostly just using it. And not changing it all that much. I have some ideas at the back of my mind, but I'm quite satisfied with it right now. Like it's pretty good for what I need. This is just like a thing that a robot made from the Git history that's probably not very interesting to you, but it is quite interesting, I think, that it started out as a bash script. And I took quite a long time before I gave up on bash. I used it quite a bit to build itself when it was still just a bash script. And then at some point, I was like, okay, maybe this needs to be something else. And I did a cool thing with the robots. I got them to like, I got one to write it in Go, one to write it in Rust, one to write it in Zig, I think. And then we kind of like compared the implementations and what the trade-offs were, and I settled on Rust. So that was fun. Yeah, so it basically gives you a thing like this in your command line, and commands that you can run to like mark an individual yak as stuck and waiting or done or whatever. That's about it basically. But the command line is like simple and clean, and easy for robots to discover and work with as well. So I found it's really good. Like if a robot has got a plan, I can just say like, right, map that out in Yaks, and it'll like draw this graph of what's got to be done. And then it can really easily see like, oh, I could do these two things could be parallelized. I can give them to two separate subagents. So yeah, feature wise, like we've got a discovery tree that you can organize. We've got states. I just added blocked recently after people sort of hassled me about it. I've been really trying to keep this simple, but I think it's quite useful to better reflect that. Um, there's sort of one context field on every Yak that's like a big natively supported description field that you can write in Markdown. But you've also got room for any number of additional custom fields. So you can just add a field about whatever extra information you need. Like I've seen people, if they've used something like superpowers to write a plan, you can store the plan in a plan field on a Yak. It also supports tags. So you can sort of model your own workflow with a tag or like mark things that are related to each other if they're all about UI or whatever. I tend to use tags for like this one's ready. So if I've like um, groomed the context in the Yak until I'm satisfied that like a robot could pick it up and work on it, I'll tag it with ready, and then that's kind of the cue for them to pick off and start working on. The syncing is really big for me because I want us to still be able to work in teams of humans on this stuff and not just be like solo heroes riding the robots. So the sync is really important to me. And it seems to be like I've got a few people using her work. It seems to work pretty reliably. But I'd love more people to test it out. Yeah. And because it's using Git, you've got this pretty powerful event log. So you can look back at like how the Yak map has changed over time. If you're interested, you can go back and look at something like how did we build that thing? What was in it? This, to be honest, the features around that are not very mature yet because I haven't had a lot of pull, but it's all there. It's all there in Git, so we could pull it back out if we wanted. Um, yeah, I think that's the interesting features. Um, yeah, and really like what I thought about is Yaks has got Beads has got tons of features. You have to categorize every bead. Is it an epic or a story or a task? There's so many sort of dimensions and features in there. And what I was thinking is like, what is the kind of minimal feature set that you need that you could then build your own workflow out of? So this is supposed to be like a substrate that you can do your own workflow on top of. That's my idea. Talking of workflow, should we see how the... Oh, look at that. Okay. So you can sort of see a Yak map evolving here, right? Oh, look, that one needs human. I wonder why it couldn't rename that by itself. Interesting. Anyway, yeah. So substrate. Oh yeah, I did want to talk a little bit about the dark side. Has anybody else here felt like they've sort of experienced a addiction with the LLMs? Yeah,
Yeah, absolutely.
yeah. There's a couple of good blog posts I've read recently. This one from Rachel Thomas, I liked, um, sort of drawing the parallels between the random feedback of gambling and the same sense of like, I type in a prompt or I dispatch a plan or a spec or something. I don't know what I'm going to get back. Like it's a surprise. I don't know how long it's going to take. I don't know how good it's going to be. And actually a very addictive thing. It's very different to doing TDD, where generally what you get back is exactly what you expected. Like you get a lot less surprises with TDD because you're really grinding the problems up small. This is a different kind of an experience. There's also that thing of like it takes a while to do its things sometimes, and then while that one thing's running, you've got a temptation to start doing another one. Um, and maybe while that one's running, you start doing another one, and then you're like jumping around plate spinning. And that can really be quite exhilarating and also quite frazzling. But it's very natural to get pulled in to start doing it. Has anybody read this post from Steve Yegge? This is pretty funny because he um, has been sort of amping this stuff, hyping this stuff, and then all of a sudden he writes this post in which he discovers that capitalism is extractive, which I thought was hilarious. Like as he only just noticed. Um, but yeah, it was actually I think it was like good leadership that he wrote this post. Just basically encouraging us all to go home early and take care of ourselves. One of the things I've learned that can be really helpful with this, I learned this from a colleague. This is like a way to counteract addiction in general, apparently, which makes me think again a bit about TDD. Is like, but it's at sort of a bigger scale. It's like before you sit down with the computer, with the agent to start doing some work, be clear about what your goals are, what your intentions are, and what it's going to look when you're going to finish. Like, how long are you going to be? Where do you expect to get to? So you don't get sucked into doing more and more and more, just one more prompt. Set your boundaries. And I find that Yaks can be quite helpful for that. Like I can say, this is the thing that I want to do next, and I can even give an agent context on that. Like this is what we're trying to achieve right now. Um, a friend of mine has built an orchestrator around Yaks called Yak Thing, which manages that. So it asks you at the beginning, what are we trying to do, and then it'll kind of like nag you and tell you to go home when you've done that. It's like we've done enough now. You can stop. Yeah, so I think then maybe that's all I've got left. It's just we were going to look at that. That's it. Yeah, that's what I had to say. Well, those are the slides that Claude helped me build last night when we had a conversation about what I wanted to talk to you all about. That was kind of the highlights that I wanted to share. So I could probably stop sharing now and we could have a conversation. Oh, look, it's finished. It's done all the things. It even did the thing they thought needed a human. Has anybody here played with Ralph Loops much? Do you want to talk about that a bit?
I haven't played much with Ralph Loops. Been sort of scared about token usage, but I need to start doing more of it.
Yeah. It is kind of amazing. You feel like you're getting a little glimpse of like what might be AGI or something when you see them doing stuff like this, because it is like it's just wandering around, um, deciding what to do by itself and then doing it and then deciding more stuff. It's pretty fascinating, I find. And it's so simple, right? It's such a simple idea. Like the script. Would I do that? That's not really the one, is it?
Well, and Claude's super helpful about how to create one too.
Oh yeah, yeah. Because there's a little bit of complexity I found, like around making it easy to be able to control C. But like this is basically it. This is all I do. Just tell it to read the prompt. Tell it to just run in a loop, in a while loop, um, and read the prompt. It's allowed to use these tools, and then that prompt is just like telling it to the thing you need. I think some people call it a blackboard. So Yaks is like a an implementation of a blackboard pattern. Like the movie Memento where he leaves himself sticky notes because he wakes
Mhm.
up every day with a fresh brain. Like you have to have something like that for this pattern because these agents just they start again from scratch every time. Um, but you can do it. You can do exactly the same thing with a Markdown file. Like just tell them to leave themselves notes in a Markdown file, write a to-do list in a Markdown file. Yeah. Anyway, it's fun. I can probably stop it now and stop wasting the tokens, though. Shall I stop it? I'll stop it. Oh yeah, the other thing I noticed that's fun about having a Ralph loop is you if you like see it's going off the rails or whatever and you don't like what it's doing, you can just change the prompt file and save it, and then the next loop will just pick up those changes. It'll read them and just be like, okay, that's what I do now. So like, you could fire Martin Fowler as your refactorer and hire Sandy Metz or whatever and see if it starts to take the design in a different direction.
Do you put a
Anyway.
limit on your Ralph loop at all?
I didn't in that one. I mean, just like while I was in this call. But honestly, yeah, when I've used them on real code bases, I have like been pretty scared to let them run for very long. So I've tended to just like make it like a shall I do 4 loops? That'll probably be about right, and then just let it run 4 loops and stop. I think the ideal thing is if you've got this is starting to get into more orchestration patterns, right? Where one agent is doing an implementation and then some other agents are judging whether the implementation has like met your overall criteria yet. And if not, it goes back around the loop. But if yes, then it can exit the loop.
And you can layer that with, if you run this loop 10 times, exit out.
Yeah.
Yeah.
But that is where we start to like move more towards the dark factories. And I think you the more you want to be able to like let go of the reins like that, the more you need these harnesses to make sure that the work it's producing is it's converging towards good.
Yeah.
But it was really interesting hanging out with this guy, Justin from Strong DM last week. He talked about like trying to achieve escape velocity where like the gravity that's dragging you down is all of the work that you have to do that you're like forced to the tokens you're forced to exchange from out of your like meat computer with the machines and just always be thinking about like why do I need to do this? Is this something that is this a check that I could get a computer to do instead? And like
Mhm.
try and lift yourself up to this level of where like they're only bothering you when it's really something that you need to decide about. It's something about like what do you value, what do you prioritize, what do you want next, or like it was unable to do this adequately and it's going to need you to step in. But just to always be looking for that.
For me, there's when I start looking at it, it's how can I get feedback quickly? That quickly turn very, very easily turn to unit tests and automated tests of some sort to get feedback. And then layering in how do I make sure that I have unit test coverage, which is some, download a code coverage tool and install that, and layering on the process to shave the yak, essentially, to start automating. Going back to my early day careers, is the best developers I knew were lazy developers. And I'm not talking people that didn't want to work. I'm talking about people that saw something that they did multiple times, then let's find a way to automate it.
Yeah. Yeah.
So automate all the things and
There
put
is, I
checks in
think,
place.
have
Go
you,
ahead.
if any of you experienced this though, that there's like a sort of existential fear when you're layering more and more of these things into machinery where you're thinking that you're doing yourself out of a job. Like I'm putting in, the skills I know about event sourcing, I'm writing them down in a skill so that one of my agents can do an architectural review on whether we're following event sourcing patterns properly. It's like, okay, wow, the machine's able to fault find this design. Where am I adding value anymore? It is a bit, I find it a bit scary.
I there's a little bit of that, right? Of am I writing myself out of a job type of thing. But I think that for me, I feel comfortable that, that the LLMs, the models that can't do what I do, can't see. I mean, they can come up with lists of like, oh, here's good refactoring that you should apply. Here's some things you missed, maybe these tests. But I think there's something there that I'm like I'm still going to need to be here to understand and check. So, but then I worry more about sort of the new to the industry developer, the junior or the like that I worry more about because we have this as a senior or someone who's been in the industry for a long while, I have this knowledge about all things surrounding the stuff that I'm asking the LLMs to do, right? As opposed to just coming into the industry and suddenly learning just how to prompt and then accepting that what I get back is the right thing.
Yeah, I was at a talk last night, local like community meetup, and somebody about my age was talking about when he's first started, and um, they sort of were just moving from using assembler to using C++, plus plus, and there were all these gray-haired developers at the time who were complaining about the kind of assembler that the compiler was writing, and they were like, this is shit. It's not as elegant as my assembler would be, and so, drawing the parallels obviously with now, but I think there's something there about like being able to know, like understand the next layer down that you're working at. It helps you to know how to work with that medium, right? Like I'm sure you're a better C++ plus plus developer if you understand about assembler and how the compiler works. And in the same way, I think we're better at prompting agents because we understand how these programming languages work and the architectural patterns that we can put into them. And yeah, I mean, I was just encouraging a junior yesterday to like take as much time as he needs to write code by hand. Where he's working in an Elixir code base, he doesn't know Elixir, he's not written Elixir before, and yeah, you need to develop like a visceral sense of the affordances of that language to be able to
Mhm.
help the agents to be able to use it effectively, I think. But yeah, whether we'll all have the sort of patience to give the juniors that time, I don't know, but I think it is important.
I jokingly say that there's there's going to be a reckoning that is going to happen in about anywhere from 3 to 5 years, where they realize that the juniors haven't been brought up, and a lot of the senior developers start to retire and push out, and they're going to be trying to figure out how to get their pipeline going again. Lots of work for us senior developers to come in and rescue projects.
And of course, nobody knows how the code works because they generated it all rather than, yeah.
Yep.
So last night I watched a YouTube video where this guy is basically saying that the future is basically juniors, junior developers generating massive amounts of code and tossing it over the wall to senior developers who are getting burnt out doing the code reviews. Um, and it's like, okay, well, this doesn't actually solve the fundamental problem that there's a gap between the juniors and the seniors that isn't being filled any longer.
No, that sounds like a really dystopian future to me.
Well, and oh my God, the amount of burnout that the seniors were experiencing because obviously doing serious code review over a code base that was generated, you know, it takes, minutes to produce and potentially an hour to go through.
Yeah.
And the other thing they're now talking about is even the senior developers are potentially being replaced with, what are they calling them? Oh my goodness, it's basically it's a staff engineer. And their job is to dive into the code when the AI code is bad, which again, I told my wife, I remember being in an Amazon elevator and they says, if you're one of these people who gets adrenaline rush from dealing with crises, come join our team. And I'm sitting there thinking, who the frick would want to do that? And this is the thing is that if if your job is either overwhelmed doing code reviews or you're overwhelmed with crashes, you know, trying to keep the system running when literally no one knows what the code really does.
Mhm.
Yeah. I'm currently using AI as a Luddite. My ChatGPT interactions do not get to see my code base. They get to see fragments of it only. And
Mm.
they don't get to write anything that I don't cut and paste over. Um, and and one of the key things in the code is tiny methods that allow me to validate that the methods do the right thing. And putting comments in the code where necessary to get it so that if a future junior or mid-level developer looks at this, they don't have to try to figure out what this method is really doing.
Yeah, well, I'd encourage you to try it, George, on a safe project. Like one of the places I found like a nice sweet spot I found with a junior I know who's 14, my kid, Torben, and we went to a game jam and we were trying to write C sharp for Unity, and I don't know, it's been years since I wrote any C sharp. I don't know the Unity um, API surface at all, and I would use Claude in a terminal next to the one that we were coding in to just like read the code and just be like an amazing Stack Overflow. So I could say to it
Mhm.
like, can you look at this function and tell me how I would get Unity to give me this information? And it would like print out a snippet of code. We could read it and then we could type it in ourselves. Because Torben really wanted to type the code in himself. He didn't want to have the robot just generating code that he didn't understand. He wanted to learn. But you could have this thing there as like a coach,
Oh,
which
that
I thought
sounds
was
good.
like a really nice pattern.
Yeah, that does sound like a nice pattern. So, and it makes it potentially more reasonable to have two different AI sources. One that writes the original code and the other one that potentially evaluates it and gives you alternatives.
Yeah.
So one of the things that I've talked with both the Claude folks, Windsurf folks about is finding a way to empower the use of multi-models and not only, obviously with the Claude folks, they're only thinking about the Claude model, but Windsurf is like, is there a way that you can have an orchestrator or a choreography agent that is maintaining things and can interrupt and can schedule one reviewer using one model like chat gpt, and then the other agent that's writing it is using opus 4.6, so you get the best of both worlds. You have different models going in, analyzing and switching roles and interrupting and saying, nope, you did that wrong, got to go back and do that again.
Yeah.
They Yeah.
This was a pattern I learned from Justin McCarthy last week was how there's the three big brains, right? The Gemini, the GPT, and the Claude. They're all trained differently.
Mhm.
They have different strengths and weaknesses, just like having a diverse team of different people with different backgrounds, you'll see different things. Um, they will see different things. If you get the three of them to review something and then synthesize their feedback, you won't see three times as much stuff, but you'll probably see 50% more than you would have seen if you'd only pointed one model at it.
Hmm.
It's really interesting. I mean, you obviously need to be able to afford the tokens to pay all three model providers. But it's really interesting. And it was interesting talking to somebody who's had so many cycles of using all three of the different models because, like, I've really only used Claude. Um, and it was almost like talking to a sommelier when you're someone who just can just about tell the difference between red and white wine. You know what I mean?
Hmm.
Um, because he was like, well, Gemini's like, I think Gemini's probably the cleverest of all of them because Google have got a lot of like good training stuff, but the post training is kind of weak, so it's got like drunk hands. You don't want to let it touch the code.
Hmm. Hmm. Yeah. Yeah. And I'm not I'm not an expert with multi models beyond Sonnet and Opus. But what I've heard from folks is that you can almost look at the code that's written and tell which model wrote it. Yeah.
Yeah, I don't have that much practice with it either. The other thing I've noticed is Codex. Like I've been using Codex a little bit now, or the GPT models, and they seem to be like they're so sort of like grumpy compared to Claude. Claude's really sort of almost obsequious, isn't it? Like, what a great idea.
Uh,
Um, you're absolutely right. And Codex, you get none of that. Codex is just like a super business-like grunt. It's just like, give me the tasks, I'll do the tasks.
yeah.
Thanks.
Yeah. I don't like the sycophancy of Claude. Well, this is a great discussion. I'm going to go ahead and end this here for now. We can keep talking, but I'm going to stop recording. One thing, next month we will have David Bernstein coming and talking to us. He's obviously very AI forward with a lot of things. And please join us. Matt, thank you so much for coming. It was wonderful to see you at Agile Open Northwest. Hope to see
Yeah.
you next year. And yeah, I'll stop the recording. Thank you.
Yeah, I'm